Hello everyone, this is Mr. Donaldson, and today's lesson is going to be about parallel lines cut by a transversal. If you remember from the previous video, we learned about angle relationships that are formed. Here is a review of those angle relationships. First, we have alternate interior angles. These angles are congruent, and in this diagram it would be angle 3 and angle 6, as well as angle 4 and angle 5. For alternate exterior, these angles are congruent. We have angle 1 and angle 8, angle 2 and angle 7. For vertical angles, these are congruent. We have angle 1 and angle 4, angle 2 and angle 3, angle 5 and angle 8, angle 6 and angle 7. Same side interior, these are supplementary, which means they add up to 180. Angle 3 and angle 5, angle 4 and angle 6. Same side exterior, these are also supplementary, angle 1 and angle 7, angle 2 and angle 8. And finally we have corresponding. These are congruent. We have angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. Now, using what we know about these angles being congruent or supplementary, we can start to fill out different angle measures of this if we're only given one angle measure. And let me show you. For this illustration, I'm going to start with the color green and write my first angle, angle 1, in the color green. Now I will write the angles that are congruent to it based on my angle relationships. Well, I know vertical angles are congruent, so that means the one diagonal here would be congruent. I know alternate interior as well as corresponding angles are congruent, so that means that this would be congruent. And again, the vertical angle for 5 would be congruent, so that would be congruent. So we see that the angles in green would all be congruent. That means if one is 50 degrees, then all those are 50 degrees. I will now write the other angles in blue. So let's start with angle 2. Well, what's congruent with angle 2? Well, that would be the one diagonal, which is angle 3. According to alternate interior as well as corresponding, that means angle 6 would be congruent, and the vertical angle from that would be congruent. So I only have two different colors, which means I only have two different angle measures, and we'll go to that in more detail. Here's what I like to call the shortcut method. If I know one angle, I can draw a zigzag to get to the other angles, and let me show you. If I know angle 1, let's draw a zigzag. Here, here, and here are equal. That means this one and these are equal. And then I draw another zigzag from here to here to here to here. These are equal. And you're going to see how this works and how it can quickly fill in this angle relationships. Here's how we use this new information. I see my diagram, and it shows me at the bottom the measure of angle 6 is 115 degrees. I can now find all the other angles just given this one angle. So the first thing I'm going to do is label angle 6 as 115 degrees. So what can I fill in? Well, I know vertical angles are congruent, so if angle 6 is 115 degrees, that means angle 7 is 115 degrees. And from here, I can either use alternate interior, alternate exterior, or corresponding angles to fill in all the other missing ones so far. Or I can use my zigzag method. If angle 6 is 115 degrees, that means angle 3 is 115 degrees, which means angle 2 is 115 degrees. So now we have to figure out the missing one. What do you know about other angles? In a diagram like this, angles are either congruent or they're supplementary, which means they add up to 180 degrees. So for example, I know that same side interior have to add up to 180 degrees. So what would angle 5 be? If angle 3 is 115 degrees, I know that I have to add 65 degrees to that to get 180 degrees. And now I fill in the rest of my chart. Angle 5 and angle 8 are vertical angles, so that would be 65 degrees. Let's go a different route. Angle 8 and angle 4 are corresponding angles, so that would be 65 degrees. And angle 1 and angle 5 are corresponding, so that would be 65 degrees. And there you have it. With just one angle, we were able to fill in the rest of this chart. Sometimes algebra gets involved. Now, I can hear you moaning through the screen right now, and that's okay. But it's pretty simple if you just take what you know and apply it to how to solve equations. So in this diagram, I'm given that these two angles, one is 3x plus 10 and the other one is x plus 40. And I have to figure out what x is. First, you have to remember, what do you know about these angles? Well, looking at the diagram, I see that these angles are they are alternate interior angles. And what do you remember about alternate interior angles? They're congruent. That means they're equal to each other. So what I'm going to do is take my first angle, 3x plus 10, and that equals x plus 40. Now you solve for x. First thing I gotta do is move my x over. So I'm going to subtract x from the right and x from the left. When I do that, I get 2x plus 10 equals 40. Now what do? You subtract 10 from both sides, and I get 2x equals 30. Almost there. What do now? Divide by 2, which means x equals 15. So if it wanted you to find the actual angle to figure out what that is, what you would do is plug in 15 into either one of those. So I'm going to pick this one. 15 plus 40 equals 55. That means this angle is 55 degrees. And from there we can actually figure out all the other angles like we did in our previous example. Let's look at one final example of when algebra gets involved. Hopefully you're not complaining as loudly as you were last time because you now know what to do. What you have to do first is think about what are these two types of angles? What relationship do they have? If you remember from the angle relationship videos, you will know that these are same side exterior angles. And what do you know about same side exterior? You know that they are supplementary, which means they add up to 180 degrees. That means I need to put these together and add them up to 180 degrees. So I have 3y minus 5 plus 2y plus 20 equals 180. And now you solve your equation. Let's combine like terms. 3y plus 2y is 5y. A minus 5 plus 20 is plus 15. And that equals 180. What do I do now? I subtract 15 from both sides. And I get 5y equals 165. Now, I divide by 5. And y equals, if I solve that out, I would get 33. So y equals 33. But if I have to actually find the angle, what I have to do is plug 33 in for y, so pick either one to plug in. I'll pick that one. So 3 times 33 minus 5 equals what? 3 times 33 is 99 minus 5, which means that angle is 94. And then if you plug 33 in for this, 2 times 33 plus 20. 2 times 33 is 66 plus 20 would be 86. That means that this angle is 86 degrees, and then you can fill in the rest of the angles. That concludes our video on angle relationships and parallel lines part 2. Remember, if you have any questions, you can email me at robert.donaldson@hallco.org, or you can find me on Twitter. Username is @Mr_Donaldson. Until next time, thanks for watching.